those horns? You hear those horns? Touchdown! And another Seahawks touchdown. Yeah! Oh! Everybody loves the Hawks. Everybody, especially Cardinals fans. Cardinals fans love the Hawks a lot more than they like the Cardinals because the Hawks are blue and green. And they eat fish, Seahawks do. Cardinals, they're just a dumb red bird that does nothing but go around and make peep sounds eating seeds. How can you like a seed-eating bird? Well, that got me all riled up. But anyway, let's hope the Seahawks put defensive back on the coordinator and they actually have a defensive coordinator for this game. I don't know. I had an interview with Pete recently and he didn't even seem to know what defense actually was. What are you gonna do? We got an interview coming today too though. And he should be here and he's... There he is! Yeah! Let me type it so I can hear my guest. How you doing, Marshawn?
Yeah, I'm on here so I don't get fined.
Well, yeah, I agree. But I don't think you were going to get fined for not being here.
You know I'm here, so I don't get fined.
Okay. Well, what I wonder, you know what, look. You see that? See what that says? That says right there, that says Super Bowl 49.
Why are you bringing that up?
Oh, that got you interested, didn't it? You remember what Super Bowl 49 is, don't you, Marshawn? Yep, that's right. That's when Russell threw the interception. That lost the Super Bowl. Yep. No, but you...
I'm only here so I don't get fined, boss.
So you're still saying that?
And don't forget the chips.
Okay, I won't forget the chips.
Towards the night before game day, and all through the house, not a creature was stirring.
Okay, I won't forget the chips.
And I told them, don't pass the ball. I have 4 runs to get in the end zone.
Okay, well, I think Marshawn is still angry about not getting to run the ball.
I'm only here for the cheesecake.
Well, thank you very much for coming by, Marshawn. And whatever you're doing, I hope you're doing it well. Bye-bye. Okay, guys. That was nice of Marshawn to pop by. Too bad he's not playing for us anymore. I don't think he's playing at all, as a matter of fact. But anyway, so what are we going to do today? We are going to continue talking about that. Examine one interaction between cognition and physiology in terms of behavior. Okay? Now, I'm going to put a link to a video in this video that you need to watch. We would watch it in class had this been a normal year, which it is not, so that's why we're not watching it in class. So, but you absolutely have to watch the video. And it takes about 15 minutes, 10 minutes, I don't know, somewhere in there, 12 minutes maybe. It's an excerpt from a longer video, but it'll give you an example of things. But anyway, so before I get into the subject material that I'm going to talk about, now remember this is the question. When the last video I did on on Alzheimer's disease, well, this one's on amnesia, on Alzheimer's disease, it's examine one interaction between cognition and physiology in terms of behavior. So there's some points here. Basically, this question is asking how thinking and physiology, biological structure are interrelated, such as how biological structures affect thinking and cognitive reality, how the brain affects cognitive reality, and how thinking can affect biology. Cognition can be defined as internal mental processes. So this we know, this is a little bit of a review, just kind of reminding you at the beginning, and plus repetition is very helpful. So that's why I'm doing it. So enter this guy. I think my batteries are starting to be a little bit dodgy. Okay? Now, we're going to talk today about Clyde Bering. I've mentioned Clyde Bering, but I'll talk about him in a minute. Well, anyway, I'll talk about him now. Clyde Bering was a guy who contracted somehow a viral encephalitis. And encephalitis is, Usually kills you, it doesn't always. And if you don't die from it, you probably, if you remember, might have wished you had. It's a very, very bad disease. It's the inflammation of the brain. I think it comes from a few different things. I know you can get it from mosquito bites in certain parts of the world, in the tropics. It's rare, quite rare, but it's a bad one. And if you're going to go to the tropics to get your viral encephalitis shot, yeah, it's worth it. But anyway, so amnesia. Amnesia is this. It's the inability to learn new information or retrieve information that has already been stored in memory. Okay? You either can't learn new stuff or you can't retrieve it. Amnesia is a condition in which people lose their ability to memorize or recall information. Okay? So there's two different types. Clyde Bering was unfortunate enough, and I've mentioned him before in a video. Clyde Bering was unfortunate enough to be affected by both. He basically burned out his brain. The disease really messed up his brain a lot. It wiped out pretty much his hippocampus. It wiped out memory centers of his brain. And if you can't memorize new things and you can't remember old things, you live in a 30-second period. And like I said, I've mentioned this before. Clive Wearing is the guy that lives in a 30-second reality at the very most. He doesn't have memories of the past, and he can't make new memories, and so he just lives in this 30-second loop. I won't get into it too much because the video that you guys are going to watch does a much better job of explaining his reality. It's tragic. Tragic. I mean, he can't remember it anyway, but still, it's absolutely tragic. It's horrific. And so he used to be a famous piano, or famous concert, what's it called, chamber choir person. You know, within that niche he was well known. Anyway, whatever, we'll watch the video. Okay. And so, whoops. Yeah, anyway, there's an interaction. So basically this is kind of how you would tie it to the topic, but we're going to look more specifics in a second. There is an interaction between biological and cognitive factors. Amnesia has a biological cause, okay? And it affects cognition. In amnesia patients, episodic memory is affected to a greater extent than semantic memory. You have to know these terms. Episodic memory. Look at the main word, the root word, and there's an episode, right? An episodic memory are the things that you think about as memories. Like, what did you do last summer? What was a fun memory you had last summer? You could call that an episode in your life. That's episodic memory, the thing that we think about as memories. Those are episodic memories. You know, like think about narratives, stories in our lives, things that we talk about, blah, 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 blah. Now, semantic memories are memories which are about the meaning of things. So let's say the economy crashes. If I'm going to say, what happens if the economy crashes? Right? That's not really a memory, that's more of a concept in your head. It's what we call a semantic memory. And whenever you see the word semantics, it means the meaning of things. The study of semantics is the study of how language creates meaning. Semantic means the meaning. And so your semantic memories are more well intact, but those can be damaged too, because there's not a clear line between semantic memories and episodic memories. Okay, but anyway. And but those are two different types of memories, and you need to understand the difference between them. And when you can ask me if you don't understand this, and I'll clarify it a little bit better, and I will bring it up in class. But anyway, okay. So that's the kind of thing. Episodic memories are the stories, the thing we think of. Memory semantics are the more of the constructs, the sort of mental, physical concepts of, what it means, that you need to pay bills, and that, a refrigerator contains food and it keeps things cold, and toilets flush and stuff like that. It's more of a semantic memory. Okay? Like who your parent, whatever, okay? So that's the things. And so, what are some of the causes of amnesia? Injury, strokes, infections, specific drugs, like sedatives. Meth can burn out people's memories. That's not a sedative, whatever. Closed head injuries, that means like a concussion, closed head instead of an open one. I mean, an open one can be that too, but it means like when you have bleeding in your brain. A concussion is a bruise on the brain. Think about this. A concussion is a bruise on the brain. Now, why do you get a bruise? If somebody hits you or whatever, you run into something, you get a bruise, well, it's because you burst blood vessels under the skin. You get a bruise. A concussion does exactly that. That's why they're so dangerous, because you're bleeding in your brain. And the concussion can be, I mean, we have millions of capillaries in the brain. And the concussion can be severe, you mean lifelong damage from a concussion, or it can be mild, you know, or if you get multiple concussions like in football, you can be damaged later in life. Okay? Your memories can be messed up. Those are close head injuries. Bilateral strokes on both sides, chronic alcoholism, Korsakoff syndrome. It always makes me laugh. There's actually a bottom shelf, I've seen it before, bottom shelf, very, very cheap vodka called Korsakoff's vodka. And every time I've seen that, I start laughing because there's something called Korsakoff syndrome. But anyway, and Alzheimer's disease causes amnesia for the reasons that we talked about last time, because it actually destroys the sort of memory centers of your brain. So let's go on. I need the batteries. You kind of defeats the purpose to have to stand here. Okay? Here's some regions that are affected. Medial temporal lobe. Those areas of the brain. I'm going to put those over here. You'll see it. The diencephalon, subcortical stuff that's below the cortex, inside the brain, medial temporal lobe, cortical, and the hippocampus, okay? Which is subcortical, it's inside the brain. Those are the areas that are affected. Like I said, those pictures will go up here, and you can take a look at them. Those are kind of the memory centers of the brain. All right? Nothing's working. Okay, anyway, now, there are two different types, main types of amnesia. Anterograde. You got to know the difference between these. Anterograde amnesia is impairment in the ability to recall new information. That is, you can't form new memories. Like, hello, how you doing? Okay, my name's Mr. Stewart. It's really nice to meet you. "20 seconds later, hello, how you doing? My name's Mr. Stewart. It's really nice to meet you." And then again and again. I would not be able to remember anything. I could leave the room and come back 20 seconds later, or you could leave the room and come back 20 seconds later, 30 seconds later, and I would not remember that I ever met you. As a matter of fact, I couldn't even remember what I was talking about at the beginning, at the end of a sentence, if the sentence is, or the discussion is 20 seconds or 30 seconds long. 30 seconds, let's say, long. I'd forget where I even was. I'd forget what was even going on. So really, you can't form any new memories, and this is because your hippocampus has been damaged. And hippocampus is, remember you guys, transferring short-term memory to long-term memory. Okay? Now, localization of function. Hippocampus, Clyde Bering works for that. Okay, retrograde, that's what we usually think about in amnesia. Like, oh, boom, she gets hit in the head. Somebody tries, it's a stupid, series. Bunk, push her off the cliff. Ah, but she lived, but she has amnesia. Oh, who is it? Who is it? I don't know. She knows, but she's got amnesia. We're waiting all season for her to get her memories back. The tension. Right? That's that kind of amnesia, where your memories are gone. Retrograde. Anterior means into the future. Retro means into the past. Retro, yo. All right? We'll take old stinky clothes and call them retro and put them in a shop in Seattle and sell them 5 times more than they cost when they were new. All right? Impairment in the ability to recall old information before the onset. Okay? Inability to recall old memories, retro is old. Okay? So there. So you gotta understand those two. Nothing more to say about that. Really? Work! It didn't work to yell at it. All right? So here's a couple studies. Remember, always wear a helmet when you're doing things. When you're skiing, when you're skateboarding or longboarding, since skateboarding's uncool or something all of a sudden. And that kind of stuff. Wear a helmet. Don't worry about your hair. That's easy for me to say, but. Okay. HM. They abbreviated his name. Everybody knows his names anyway. You just call him HM, then you don't have to remember a name. First fell off his bike at 9 years old, resulting in brain damage. Whacked his head. Epileptic seizures. Okay? He had epileptic seizures. It caused problems in his brain. He had epileptic seizures. Major seizures happened up since the age of 16. It got worse and worse. Drugs failed to control it. At 27, he had brain surgery to control his epilepsy. He had a bilateral medial temporal lobotomy. They removed tissue from the temporal lobes, including the hippocampus. Okay? So, they removed some tissues out, including the hippocampus. I don't know. I mean, this is a long time ago. He was studied extensively for 40 years. In 1997, researchers used an MRI scan. They finally got that. Whoops. Okay? Now, basically, he couldn't make any new memories. He had some of his old memories left, but he couldn't make any new memories. The hippocampus is needed for memories to be transferred from short-term to long-term. I've said this a bazillion times, so I don't really need to go any deeper into it. It's just an example of how it's a good case study for explaining how you could approach this question should you get it, which you will at some point in time. It doesn't necessarily have to be in the IB test, it could be in an in-class test. But yes, this is important stuff. The case of HM reveals the interaction of cognition, memory, and physiology. Brain damage is relevant areas of cause of memory. Studies suggest that certain brain regions are responsible for cognitive process of memory. That's kind of an answer to the question, an outline of how you would answer the question, okay? Wait. Well, somebody's calling me. But I'm gonna let it ring, because I'm gonna prove to you guys I have friends. That's right. I'm gonna turn it off. So, probably wasn't a friend, it's probably a robocall. I think it was some weird number from somewhere. All right, so the next slide here, I'll just do this, it seems to be a little easier. This is not for me to go over in class with you guys. This is for you to see. Remember when you do the evaluation of studies, and I said that the 22-point questions need evaluations of studies? This is simply strengths and weaknesses of the study, so you can do a proper evaluation. Just pointing it out to you. Okay? We can talk about it a little bit in class, but I'm not going to go over that right here, right now. Here's another study. Here, Clyde Bering. Okay? You'll watch the video, you won't forget it, well, unless you get viral encephalitis. God forbid. Okay, that's the case. He was a musician. I'm just going to do this one briefly because you're going to watch the video and see it. But it's a very rare case, okay? The musician who got viral infection left him with serious brain damage. Like I said, it messed up his brain all over the place. They talked about in the video the parts of the brain. It's just pervasive. It was massive brain damage. Massive. And so he ended up with retro and anterograde amnesia. Okay? He could not transfer information from short-term to long-term memory. His memory lasted 7 to 30 seconds. He was unable to form new memories. He still had the ability to talk, and so on. And one of the weirdest things in the world is to watch. He can sit down, and it's in that video. He can sit down in front of the piano and still play professional and skilled stuff. He can sit there with all this massive brain damage. He can sit there and still. It's something. It's a very sort of weird thing to see because he's completely incapable of knowing where he is, what's going on, knowing who's what, what's when. He plays solitaire. They call it patience, or patience, in Britain. He's British. Playing patience, English, specifically. Anyway, he can do all these things. So he's got, semantic memories down still, but okay. Where is episodic memory? Remember, that's memory of stories. And some of the semantic memories were lost. MRI scans of Waring's brain showed damage to the hippocampus and some of the frontal lobe regions. So he's got it all over the place. It's really bad, and he's really old now. I think he's still alive, but I'm not really sure. All right, and so the conclusion here, and now it's basically the same conclusion. This shows very conclusively, being a conclusion, this shows very conclusively that these different parts of the brain affect the cognitive process of memory. Okay? It's a very good answer to the question of the interaction between physiology and cognition. And that's what the question is asking. So Clyde Bering is an example. There's a whole bunch of examples here, and I'm going to do one last one for this video. There's a whole bunch of examples. I mean, you've got all those studies that are around the amnesia stuff, and so on and so forth, and then, not the amnesia, the Alzheimer's. There's 5 studies in there I mentioned for the Alzheimer's, and then there's these case studies here, and they're all good. They're all really, really good. When we get to studying for exams and stuff, it's good for you to make like little note cards or flashcards with the study names on them, so you can just kind of repeat them and repeat them. We'll get to that later. And also here, that's another strengths and weaknesses thing. I'm not going to go over it. There's no reason for me to go over it here. It's something for you to look at. The strengths of the study, the weaknesses of the study. And then one more thing, concluding thoughts about amnesia. It's basically what I just said. I've said the entire thing. So I don't need to repeat it again for the sake of the video. Remember, my PowerPoints are both for presentation and they're both for you to use. And so some of the slides are not really meant to present to people. They're meant to say, okay, take a look at that when you're doing your own study and stuff like that. But we will look at one more study here. And this is kind of an interesting one. So what this study, this is done in, I think this was in Korea, if I'm not mistaken. And they wanted to see if meditation caused any changes in the thickness of the brain. This kind of goes along a little bit better with, but no, it's interaction between cognition and physiology. It goes well here because cognition is like meditating, doing, thinking with meditative things and seeing if it changes the brain at all. It's the other way around. For the other ones, the other two I mentioned to you are the brain affecting cognition, and this is cognition affecting the brain, and that's why it's in here. But anyway, so a total of 46 meditation practitioners, 16 men and 30 women, and control subjects were used. Those are the participants. The aim is to see if the aim of this study is to see if meditation affects brain thickness. If cognitive, okay. Anyway, the meditation practitioners were trained in a certain type of meditation, Eastern philosophy, to elevate human awareness. So here's one of the weaknesses, this one here, I'm going to walk over here even. It said the mean meditation practice was 41 months, which, 3.5 years plus or minus 27 months. So some people were only doing it for about a year, and other people have been doing it for many years, for 6 years. So it's kind of a weakness because it's such a wide range of people. But okay, fair enough. It's okay. And then control subjects had no previous experience with meditation. And this slide basically just shows the areas of the brain where things were thicker. And if you look at the meditation group is over here, and they have more thickness in different parts of the areas than over here. If you look at the colors on the thing, it'll be over here. If you look at the colors on it, you'll see that there's a more thickness into the thing. But this next slide is a little bit. Now they put a bunch of slides up here. I don't need to show them all. This next slide is actually pretty good. It shows that during during more meditation, that people generally have an upward sloping thickness of their cortex. So it's showing that in certain areas. So it's showing that this meditation actually does something to change the structure of the brain. This is not strange. We see the exact same thing in the taxi driver study, the McGuire taxi driver study, where the hippocampus actually has different forms. And we also see this in the juggler study that I was talking about, Draginsky study, when they're juggling and it actually changes parts of the brain. So it's not unexpected, not at all unexpected. But the specific with this one is it's showing thinking per se. But you could also say juggling is thinking, and you could also say learning the London map is learning the streets of London is thinking. So it's really not doing much else than the other studies we're already talking about. But it is kind of interesting. It's nice to get a study that's not necessarily based in the West either. Okay? But anyway, so basically the findings are meditators have a thicker cortex. I don't need to read the whole thing to you. In parts of the brain, and they had a thinner cortex in other parts of the brain. Simple as that. It changed, the meditation changed the way people's brain structure. It changed the brain structure. So the thinking process changed the brain structure. So that's basically the idea. An evaluation, I'll just go over this one a little bit. Okay. It's a vague grouping, a meditation or practitioner. Now remember, kind of like the taxi driver study when I was talking about that one, kind of like that one, this is not an experiment. This is more of a quasi-experiment. And the reason is there's no independent variable. You're just studying two groups of people. These people meditate, these people don't. So you're not necessarily at all. There's no control. And maybe people with a certain brain form like to meditate. Maybe the meditation doesn't cause the brain to change. Maybe people have a different brain, so subsequently they're more interested in meditating. Now this is possible. It's possible. And so this is a major weakness because it's not a controlled study. But you can't. These people are meditating for years. You can't lock them up and control them in a lab. It's got some validity. It's got ecological validity to a certain extent. Fairly decent ecological validity, meaning it has something to do with people in reality because it's not in the lab, but at the same time, it's not a controlled group. And so that's a weakness to the study. For instance, how many hours a day are they meditating? When is a thought meditation and not meditation? If I'm thinking about, or do I have to be thinking about existential questions like the meaning of life to be meditating? Or if I'm thinking about the best way to pragmatically go through my work day, is that meditating? I don't know. What is meditating specifically? That's some of the other problems. It's correlational, not causal. So they can't show a cause. It's just a correlation between brain thickness and things you do in your life. Okay? And it's a well-organized, it's not really a lab study. That's incorrect. Well, it is a lab study, but it's not a lab study. It's in a lab. Yes, they're doing it. They're looking. It's lab in the sense that they're looking at MRI and that type of stuff. Sure, that's what I mean. But it's not a controlled lab study. It's organized. Precise with MRI, probably repeatable, probably. Now remember, in science, you have nothing without replicability. Nothing. If you cannot repeat something in science, you have one-off. You have nothing. Scientific knowledge is repeatable knowledge. Okay? That's what scientific knowledge is. And psychology is a science. So if you can't replicate something, you really don't have anything. And you probably could replicate it, but I don't know. What about how would you replicate the same exact subjects? I don't know. So that's kind of a problem, but it's still, ethical guidelines are followed, and so on and so forth, okay? And then once again, it just shows a link between thinking and cognition. There's thinking and physiology, between cognition and physiology. Alrighty. So with that, I gotta get back to my game. Go Hawks! Sitting here talking about psychology when the game's going on. Listen to that crowd. You hear that crowd? I hear the crowd. Listen to that crowd. That crowd, they are going wild out there. Listen to that. Listen. I'm missing the game. You guys should be pretty darn grateful. I paid a lot of money for these seats. Yeah, this is pre-COVID times. There's tons of people in the crowd with a $300 seat, and I came and gave up the game to teach you. Goodbye. Go Hawks! Beat the Hawks! Carlos, super red bird.